Harnessing the power of the sun to provide a clean source of electricity is gaining traction as improvements in technology and manufacturing have brought costs down significantly.
But it's more than just solar panels. There's a major effort underway to find a more efficient way to separate clean-burning hydrogen gas from water. And part of that research is taking place right here in West Virginia. The DEP's Mike Huff has the details.
It's the first day of fall classes at Fairmont State University, and the students of the incoming class of 2020 aren't the only new thing on campus. Thanks to a grant from the Dominion Foundation, the university installed this solar array to provide power to the library.
They're tied directly into the library, and it's a 4.08 kilowatt system, so on a good day right now, in the next hour, if the sun keeps shining, they'll produce 4 kilowatt hours of energy for us, and it'll all be consumed immediately by the library. We'll probably never outproduce what the library is consuming, but it's a start. Eventually, I would like to be able to have more solar panels on campus, either at this location or perhaps on the rooftops of some of our buildings.
The Dominion grant also goes to support the efforts of the Solar Army, a group centered at Caltech with chapters all over the world that's looking into more efficient ways of producing solar energy. Erica Harvey, a chemistry prof at FSU, is the research director for the Solar Army's West Virginia Brigade.
Specifically, we are interested in finding materials that can help sunlight split water into hydrogen gas and oxygen gas. So that would make a fuel, hydrogen, which is completely clean burning, no carbon involved at all.
Hydrogen can be stored and then used to create electricity using fuel cells. It's the most abundant element in the universe, but on Earth it exists in compounds with other elements. Water, for example, it's the H in H2O. Splitting off the hydrogen takes energy, and the Solar Army is looking for ways to do it with less, making the process more efficient and therefore economically viable.
I think this is an awesome project. So this summer I actually was able to go to Caltech for 6 weeks and mentor on this research for high school students. And so now I get to come back with what I've learned and do even more research with all kinds of areas of solar energy research. Here in my hand I have a plate. It's actually conductive glass, which contains spots of different metal salt solutions. So imagine a little piece of metal, but that's small. And we put it on here, and what we do is we flash light through it to simulate sunlight. So what we're looking for is a way to split water with a material using sunlight. So these little spots are different combinations of solutions that might potentially be the catalyst, the thing that speeds up this reaction that we're looking for.
And while this solar array is only making a small dent in Fairmont State's energy budget, its value in education and outreach may be its biggest impact.
These solar panels are intelligent, so they are reporting out to the internet every 5 minutes on their production. And we can take information like that and be able to use it in our classes. I want to tie in the electronics program, electronics engineering technology program that we have here, the computer science, physics, chemistry. We can do a lot of good with this information that's being generated in our classes. And having these on campus, basically a visual reminder of what we can do with free and plentiful solar energy to be able to do something productive with it.
In Fairmont, I'm Mike Huff for Environment Matters.
The Solar Army is funded through a grant from the National Science Foundation.